Welcome to Frost and Sullivan's Growth Podcast. In today's episode, we examine how quantum technologies are reshaping the future of data centers and why infrastructure leaders are increasingly preparing for a quantum-enabled future. The exponential growth of artificial intelligence, high-performance computing, and data-intensive workloads is creating unprecedented pressure on digital infrastructure. At the same time, rising energy consumption and emerging cybersecurity threats are exposing the limitations of existing approaches to infrastructure management. Could quantum technologies fundamentally change how data centers operate, secure infrastructure, and create new sources of value? Let's explore 5 important questions shaping the future of quantum-enabled data centers. Why are data centers paying attention to quantum technologies? Data centers are entering a period of unprecedented complexity. Artificial intelligence workloads continue to grow, energy requirements are increasing, and infrastructure management is becoming more challenging. Classical computing approaches are increasingly struggling to optimize highly complex environments involving thousands of interconnected variables. Quantum technologies are emerging as a potential solution because they offer entirely new approaches to optimization, simulation, and secure communications. For infrastructure leaders, quantum is becoming less about scientific curiosity and more about preparing for the next phase of digital infrastructure transformation.
What problems can quantum technologies actually solve? The immediate opportunity is not replacing classical computing. Instead, quantum technologies can augment existing infrastructure by solving highly complex problems more efficiently. Quantum computing has the potential to improve workload scheduling, resource allocation, and energy optimization. Quantum simulation could support cooling optimization and infrastructure design. Quantum communication introduces new possibilities for ultra-secure connectivity. Quantum sensing can improve environmental monitoring and predictive maintenance capabilities. Together, these technologies could significantly improve operational efficiency across increasingly complex data center environments.
Why is cybersecurity becoming a quantum imperative? One of the most significant drivers of interest in quantum technologies is cybersecurity. Future quantum computers may eventually be capable of breaking many of today's widely used encryption methods. This has accelerated concerns around Q-Day and so-called harvest now, decrypt later attacks, where encrypted information is collected today with the intention of decrypting it once sufficiently powerful quantum systems become available. As a result, organizations are increasingly investing in post-quantum cryptography, quantum-safe networking, and resilient digital infrastructure strategies. Preparing for quantum security is rapidly becoming a strategic priority rather than a long-term research initiative.
Who is building the quantum-enabled ecosystem? The quantum ecosystem is developing rapidly. Organizations such as IBM Quantum, Google Quantum AI, and Microsoft Azure Quantum are lowering barriers to adoption through cloud-accessible platforms and hybrid quantum classical environments. These ecosystems are allowing enterprises and infrastructure operators to experiment with quantum capabilities without significant upfront investments. The growing availability of quantum computing as a service platforms is also accelerating learning, experimentation, and early commercial deployment. For many organizations, participation in the quantum ecosystem can begin today without owning a quantum computer.
Where are the biggest growth opportunities emerging? Perhaps the most exciting aspect of quantum technologies is the opportunity to rethink business models. Quantum-ready colocation environments are emerging as an attractive opportunity for data center operators seeking to support future hybrid quantum classical workloads. Quantum-secure networking and connectivity services are creating new opportunities to address growing enterprise demand for resilient communications. Quantum-enhanced optimization and efficiency services may also enable operators to move beyond traditional space and power offerings and deliver differentiated, value-added services. The strategic opportunity extends far beyond computing power. Organizations that begin preparing today will be better positioned to capture the next phase of growth in digital infrastructure. Thanks for joining us on Frost and Sullivan's Growth Podcast. Quantum technologies are beginning to reshape how organizations think about infrastructure efficiency, security, and long-term competitiveness. Understanding these developments today can help data center operators and infrastructure leaders prepare for a future where quantum capabilities become an increasingly important component of digital infrastructure strategy. For access to our research, competitive benchmarking, and best practice frameworks, head over to frost.com or email hello@frost.com. We'll be back soon with more conversations exploring the technologies, strategic imperatives, and growth opportunities shaping industries around the world.